Good morning. Somebody had asked me for some help with a problem, and I thought it would only take a minute for me to type it up and explain the solution so that they can benefit from it. Maybe somebody else that's watching might gain something from it as well. In this question, this deals with transformations, and I would describe this question as being like a full-blown transformations problem because it involves a vertical stretch, it involves a horizontal stretch, it also involves horizontal and vertical translations. And you're given the original function, it's f of x equals 2x squared plus x plus 1, or y equals 2x squared plus x plus 1. And you're given all of this information about the different transformations that occur. And I think the key to answering this question, which is that we need to find the equation of the resulting function, the key to understanding how to get there is understanding, first of all, what the four parameters are that describe these transformations. So you will have learned in class that if something is stretched vertically, and vertical stretches in Math 30-1 are always relative to the x-axis. If something is stretched vertically by a factor of 2, then the parameter a will have a value of 2. And we'll come back to what that means in terms of what we're going to do to the function with it in a bit. But I want to go through and find out and list for you all of the values of the parameters. You will have learned in Math 30-1 that the value of b, the parameter b that we're going to use in the equation, is the reciprocal of the horizontal stretch factor. So if the horizontal stretch factor, and horizontal stretches are always relative to the y-axis, if the horizontal stretch factor is 1/3, then the parameter b is 3. And I'm going to pause here for a second, just in case any of my current students are watching this video. You have not learned about what a and b do yet. We're going to be learning about that in the next lesson. When we get to h, you're told that the function is then translated 2 units to the right. So you will have learned that that tells you the parameter h is positive 2. It's positive because to the right is a positive translation. And since it's translated 4 units down, k is negative because down is a negative direction vertically, and k has a value of -4. Now, the other thing you need to know now, just before we proceed, is that the horizontal and vertical stretches always happen to a function before the translations do. So when we build this equation, we have to start with a and b first, use the parameter a equals 2 and the parameter b equals 3 to change the equation, and then we'll worry about using the other 2 parameters to change the equation further. Now, it doesn't matter which of a or b you handle first. I just prefer to go a, then b, then h, then k. I just do it in alphabetical order, the order in which they're written there. Now, the first thing is that you need to understand that whenever you stretch a function vertically by a factor of a, the new function will be that factor, or that parameter a, multiplied by the old function. So in this particular case, the first thing that happens is we have that parameter of 2, and we need to multiply it by the original function of 2x squared plus x plus 1. And we might as well simplify that before we proceed to the next step. So the new function at this point in time, just after the vertical stretch, will be 4x squared plus 2x plus 2. And all I'm doing there is I'm multiplying that number of 2 out in front by the 2x squared, I'm multiplying it by the x, and I'm also multiplying it by the 1. So that's where we're at this point in time. Moving on to b, so this is the second kind of stage of changing the function. You should know and will have learned in class, and my students will learn in the next lesson, that when you have a parameter b, in this case it's 3 because the stretch factor horizontally is 1/3, the new function will be found by substituting into the current function whatever b times x is. So this is the rule. We have a rule for step 1 which says that the change with parameter a is the function becomes y equals a times f of x. And we have a rule for the parameter b, which says that the new function becomes f of bx, which means it's going to be f of 3x. And what does that mean? Well, it means, and at this point in time, we want to be careful because we're not going back to the original function. At this point in time, we're taking this function from step 1 and we're stretching it horizontally by a factor of a third. So this is the function that we are applying the rule of f of 3x to. And all f of 3x means is we're going to take the current function. Again, the current function is this one. We're going to take the current function, and every place there's an x in it, we're going to replace that x with 3x. So we're going to have 4 times, in brackets, 3x quantity squared, plus 2 times, in brackets, 3x, plus 2. And I keep saying in brackets because I like my students to use this rule that no matter what, whenever you substitute something in for a variable in any equation, put a set of brackets around it. It's not always necessary, but it's necessary enough of the time that you might as well do it all of the time just to be sure. Much like what we did in the first step, what we should do is we should simplify this. You have to worry about squaring 3x first. We'll worry about multiplying that by 4 in a bit, but 3x quantity squared, this piece here, means that we have to square 3 and we have to square the x because 3 and x are both being squared. So 3 squared is 9 and then times x squared, which is x squared. And then we might as well multiply 2 by 3x and get 6x, and then we have plus 2. And the final step is nobody writes 4 times 9x squared. You would just write 36x squared because 4 times 9 gives you 36. So I want to back up for a second here and just tell you where we're at. After stretching the original function vertically by a factor of 2, we land on y equals 4x squared plus 2x plus 2. If we then take that function that I've highlighted in blue and stretch it horizontally by a factor of a third, meaning b is equal to 3, this is where we're landing at this point in time. So what I've highlighted in green is the original function after being stretched vertically by a factor of 2 and horizontally by a factor of 1/3. Okay, now we can worry about the translations, which are related to h and k. When you have an h value, the rule is, so we're into step 3 now. I'm going to deal with h first. The rule is that you take the old function, in this case the old function is actually what I've highlighted in green, and you apply f of x minus h to it. That's the rule. So the rule for a is it's a times f of x. The rule for b is it's f of bx. The rule for h is it's f of x minus h. And in this case, h is 2. We've determined that it's 2 because it's translated 2 to the right. And what that means is the rule, more specifically, will be f of x minus 2. And all f of x minus 2 means is that we're going to take the current function. We're going to take the current function, and every place there's an x, we're going to put x minus 2. That's what function notation tells us. F of 3 would be what we get when we put 3 in for x. F of pi would be what we get when we put pi in for x. So f of x minus 2 is what we get when we put x minus 2 in for x. So at this point, we're going to end up with 36 multiplied by x minus 2 squared. When you look at the green function, it's 36 times x squared. and we're changing that x to x minus 2, so it's 36 times x minus 2 squared. And then plus, the green function is 6 times x, but we're changing the x to x minus 2, so it will be 6 times x minus 2. And then the green function also has this plus 2 at the end. And we're really close to getting to the end. Only because the person who asked me this question told me what the answer is, do I know that you're not expected to multiply this all out. But in the Math 30-1 level, if you had this question, say, on a written response problem on an exam, and it said expand it out, then you would be expected to FOIL all that out and collect like terms. However, we're just going to stop there. And again, that's only because I was told the answer is going to be in this form. The final step is the fact that it's shifted down 4 units. So k is -4. And in this particular case, for step 4, well, not in this particular case, in all cases for step 4, what you do is you take the old function, which in this case, everybody, when I say the old function, I'm not tracing this all back to the beginning. The old function that we are now shifting 4 units down is this one. So this is a sequential stepping thing. We apply a to the original function to get a new original function. We apply b to that new original function to get another new original function. Then we apply h to get another one, and now we're going to apply k. The rule, I'm sorry, I interrupted myself and I forgot to finish writing this. The rule is that the new function will be f of x plus k. So that means I have to take the yellow function, which is my current f of x, and add k. Well, k is -4, so I'm going to subtract 4. Subtracting 4 is the same as adding -4. And that means that after the 4th transformation, which happens to be a translation, I'm going to get that yellow function, 36x minus 2 quantity squared, plus 6 times x minus 2, plus 2. I'm going to take that yellow function and subtract 4. So I'm getting y equals 36 multiplied by x minus 2 quantity squared, plus 6 times x minus 2 quantity minus 2, because 2 minus 4 is -2. And this doesn't matter what color I use. This is our final answer to this question. If you take that original function of y equals x squared plus x plus 1, stretch it vertically by a factor of 2, horizontally by a factor of 1/3, then translate it 2 units to the right and 4 units down, this is what you get. So to the person who had asked me for a little help with this problem, there's the solution. I hope that was helpful, and I hope that anybody else who's watching this found the video helpful. Take care, everyone.